Today we are going to talk about similar figures, and this is section 6-7. I have some similar figures here. You don't have to copy them down, but basically these are figures that have the same shape but not necessarily the same size, and they are proportional to one another, and that is a very key point. So here we have some triangles. Here I have some fractals. A fractal is a geometric image that can be divided into parts that are smaller copies of the whole. So can you see the repeated image again and again and again? Very cool, similar figures. Let's go ahead and get down that definition of similar figures. So again, they have the same shape, but not necessarily the same size. And most importantly, they are proportional. Similar figures have what we call corresponding parts. This is best illustrated with an example. So I'm going to draw two right triangles. You do the same. Do not worry if they are not perfect. I will note that these are definitely not drawn to scale. But they can give us an idea about what it means to be proportional. So here I have two right triangles. I have triangle A, B, C. Remember, we name them by their vertices, and triangle X, Y, Z. And using symbols, we can say triangle ABC is similar to triangle XYZ. So that little symbol there means similar. When we've written it this way, A, B, and C, then X, Y, and Z, I am saying that A corresponds to X, B corresponds to Y, and C corresponds to Z. And if you look at the drawings, you can clearly see that. Okay, so let's take a look at their angles. Similar figures have congruent angles. Congruent means the same measure. So I could say angle A is congruent to angle X. And that's a new fun symbol as well. That means congruent. Now those are clearly both right angles. But what about the other angles? Angle B is congruent to angle Y, and I'll just use a single marking there for that. And then if I look at angle C, let me use two markings. Angle C is congruent with angle Z. C and Z. So when you see these symbols, it's a way to help you line up your similar figures and figure out which angles are corresponding and therefore which sides are corresponding. And the reason why you want to work with corresponding sides is because of the fact that the sides are proportional. So if I was looking at side AC, it corresponds to side XZ, and it forms a proportion with the other sides of these triangles. So here, these are related. I can also say BC corresponds with YZ, and that BA, which is right here, corresponds with YX. Knowing that the sides are proportional could help us find missing values, which is exactly what we're going to do next. So let's go ahead and take a look at page 45. Please go ahead and get that out. And let's see how these proportions can help us solve for missing sides. So with number 1, we'll take a look at some more triangles. Just as a note, you don't have to have triangles. You could have any geometric shape whatsoever. So just to make sure you know what a quadrilateral is. Parallelograms are specific kinds of quadrilaterals. We have pentagons and rectangles, squares, all of those great shapes. So with number 1, we are given two similar triangles and we need to find side EF. Let's see how we can set up a proportion to solve for that. Let me make a little note here. Many proportions could be correct and could solve for the missing side. So if the way you looked at it is a little bit different from the way I do, it doesn't mean that it's necessarily wrong. If you do get a different answer, I would check in with me about your proportion. But if you get the same answer, most likely you are fine. So looking at triangle ABC and knowing that it is similar to triangle DEF, let's go ahead and see what we have. Well, I know side AB corresponds to side DE. I also know that side BC corresponds with side EF. Now I'm using letters here on purpose. I'm showing you that I am comparing my smaller triangle to my larger triangle. And yes, I will now fill in the numbers, but you don't just want to fill in numbers and hope that you're correct, because it's very easy to get one backwards. You might say, well, it was just a little backwards, but you need to make sure that you are using the corresponding sides when you set up your ratios and ultimately your proportion. So AB is labeled at 4 meters, and again we compare that 4 meters to the 6 meters of DE. And that should be equal to BC, which is 12 meters, and then EF, which is X. Lots of different ways to solve this proportion. I suggest keeping it simple. I immediately recognize that 4 goes into 12 really nicely. So why don't we go ahead and multiply by 3 and we'll get X equals 18 meters. Okay, so that works for number 1. And again, this is not the only correct proportion, but it is one that does work. Let's look at number 6, which has some parallelograms. And we have quadrilateral MNOP, and that is similar to quadrilateral WXYZ. Okay, so again, which sides are corresponding and how can we use that? Well, I know that if I start with my smaller one, NM compares to XW. I also know that in my smaller quadrilateral NO compares with XY to the larger quadrilateral. When I fill in those values, NM is 10 to XW, which is 24, NO is my missing value, and XY happens to be 36, I again have a proportion that I can now solve. 10/24 simplifies. I can use the cross product. Hit pause, solve it, and come back for the solution when you're ready. Okay, so when you do all of your math, however you choose to solve it, you should get X equals 15 meters. Let's take a look at number 7. 7 is a little bit different. We are given two triangles like number 1, except this time we have a smaller triangle embedded within a larger triangle. So this is why I keep referring to the sides. We want to make sure we know which side corresponds to what before we start filling in numbers. Let me start with a smaller triangle first. You don't have to. I just happen to be doing that here. So I know side JM corresponds to side JN. Notice they share the vertex J. And I know that in the smaller triangle ML corresponds to NK. Let me throw my numbers in there. That gives me 8 compared to 36. And that should equal 7 to X, because again, everything has to remain proportional in similar figures. Again, 8 over 36, you could simplify that first before cross multiplying. Please solve this and unpause it when you're ready for the solution. Okay, so when you do this, you should get X equals 31.5 meters. Cool. Taking a look at number 8, this one's a little bit trickier only because of the orientation of the triangles, and that's again why you want to pay attention to those markings and which side represents what side. If you are given some rectangles or triangles or any other shape that do not have labeled vertices, if you'd like to label them yourself, go ahead. I mean, that's fine. But in this case, I'm going to use the angles to help me figure out which side corresponds to which. So if you look in the upper right hand corner of the larger triangle, we have 2 hash marks there. The smaller triangle has those double hash marks in the bottom left, so I'd have to rotate the smaller triangle to be kind of in the same orientation as the larger triangle, and that, when you visualize that, that can help you figure out your proportion. One possible proportion here, 63 corresponds to 15, as x corresponds to 12. Hit pause and solve. Okay, so we should get 50.4 yards. Let's take a look at one example down at the bottom, number 10. Sometimes you will be asked to find a missing side, but you're not given a diagram. So you should just draw one yourself, even though 1, it will not be to scale, and 2, it might not even be the shape that they're talking about. And I'll show you what I mean. So in number 10, quadrilateral RSTU. So I know it has 4 sides. I don't know what kind of shape it is, but a rectangle pops into my head. So I'm just going to draw that and start labeling. Is similar to quadrilateral LMNO. So again, I have no idea which one is larger or smaller yet, but that's okay. I just want to get a visual. What is the value of LO, so I'm going to mark that X, if RU is 6 inches, LM is 45 inches, and RS is 9 inches. Do you see how the drawing really helps? Now you can look at it and clearly see that this is drawn inaccurately. But I can see which sides correspond to which sides, and that is very helpful. Again, lots of proportions we could set up here. I'm just going to say, let's see, 9 to 45 is the same as 6 to x. Hit pause and solve. Okay, again, when you do this, I would definitely simplify that. You can just look at it then and figure it out. X should equal 30 inches. Keep things simple when possible. The most efficient way is usually the best way to go about something. Now I'd like you to go ahead and take a look at number 1 on page 43. This is a cool looking diagram. Okay, and it's based on the art club. So the art club is painting the mural shown at the right on a wall. Triangle QRS is similar to triangle NOP. That is really important. Again, when you're trying to figure out which number corresponds with which number, you want to keep the letters straight. So I know that QR, without even looking at the diagram, QR corresponds to NO, and that RS corresponds to OP. Now that may be helpful or may not. I might need to look at some other sides, but just organizing it that way first can really help us fill out our proportion. So in part A, find the length of NO. Okay, so I don't know that. So let's see, did they give us QR? They did, that's 16 feet. I do not know NO, so I'm going to use the variable x to represent the length of that side. RS is 12 feet and OP is 21 feet. So we happen to have enough information here to find the missing length. If we didn't, again, I just would have to go back to the drawing and see, oh, maybe they gave me another side, and I could look at SQ and PN instead of the sides listed here. So please pause and solve. Okay, when you do this, you should get 28 feet. We'll save B for another time, same idea. I will see you in class. Thank you very much.